Okay, so if we start off with a triangle, this is an inclined plane problem, and I will just draw a right triangle. So this is the right angle, that's a 90-degree angle, and we have to pick this angle, theta. So, and we also need to pick the mass of the block. Gravity is going to pull straight down on that block. So I'll make up a mass of 3.2 kilograms, and I'll make up an arbitrary angle of 12.6 degrees, and I'll make up a imaginary coefficient of static friction, the friction between the block and the ramp, to be like 0.3, and there's no units on the coefficient, it's just a number. So first question is, let's find out, given the mass on the block and the acceleration due to gravity, what is this force vector? So force of gravity, if you will, equals, and we know F equals ma, so we can say F equals ma, and the a is the acceleration due to gravity, so sometimes they write it like that when you're dealing with gravity. Still means the same thing, and this little label is just for you to understand it's the force of gravity. So that being said, we'll say F equals, I guess we could keep the subscript, F of G is mass, so that's 3.2 kilograms times G, which is, G is always 9.8 meters per second squared. Multiply these two numbers and we get the force of gravity, 3.2 times 9.8, and that's 31.36 newtons. It's newtons because a kilogram meter per second squared is a newton. All right, so that takes care of, first, I should say first, we're gonna find that, and we did. So let's cordon this off with a nice polygon shape. And then we use this now to find this, because we've got to find out what, how much normal force there is, because the ramp is going to push back only as hard as it has to, and this is how hard it has to push back. So that's another right triangle, and we could also imagine the right triangle being right here. But anyways, this is essentially G sub y. It's gravity in the y direction. So second, let's find the gravity in the y direction. And the way we do that is, if we imagine that this is theta and it's 12.6, so 12.6, I'll try to squeeze that in there, then this angle is the same as that. This is 12.6 also. And if we look at our, so this is our trigonometry, so ka toa, tangent, toa, and these actually stand for opposite hypotenuse. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And what is adjacent and what is opposite depends on where the angle is. So the angle's here, so that means the opposite would be this side and the adjacent would be that side. You might be wondering why this couldn't be the adjacent, but that's because this is the hypotenuse. The side that's opposite the right angle corner is always the hypotenuse. And we've already found the hypotenuse to be this. So I don't know if I can squeeze that number in here, but 31.36 newtons is this side. So now we want to find this side. The way we do that is we use the angle. We say cosine, if we're going to find this one, that's the adjacent. So cosine of, what's the angle? 12.6. So cosine of that equals adjacent, which is g sub x, or excuse me, g sub y, over hypotenuse, which is 31.36 newtons. And as long as only one, as long as there's only one unknown in an equation, we can solve that thing. So let's pick this up and move it over here. Hopefully you're comfortable with your algebra. And I don't have to show you that you know, multiply, since this is on the bottom of the fraction, you multiply both sides by 30, and then this cancels and that cancels, and that's how this ends up there, because whatever you do to this side, you got to do that side. Hopefully I don't have to show you that. Pretty soon you just get good at this and you just pick it up and move it to the other side on the other level, because you know that's what this is going to do. All right, so this times that gives you g sub y. I've still got that in my calculator. Now I'm just going to multiply it times the cosine of 12.6. So times cosine of 12.6 equals 30.6. So 30.6 newtons equals g sub y. Why is it newtons? Because there's a newtons unit right there. All right, so now let's cordon this off with a nice little crazy looking polygon. Maybe we'll look like make this look like there's a shadow. Unfortunately, that means I probably have to do it through here too. Oh, what am I getting myself into? All right, sorry to burn up time doing that. I shouldn't have. All right, so third. Make sure my camera's picking this up. Okay, third, find g sub x. Okay, clear that. It just so happens that when you're finding g sub y, if you're also then finding g sub x, if one of them is cosine, the other one's inevitably going to be sine. So I'd say sine of the same angle, 12.6, is equal to, and this time it's g sub x, because g sub x is opposite, g sub x, opposite over hypotenuse. Hypotenuse is the same number, 31.36 newtons. Okay, take this, move it over there, 31.36 newtons. That's gone because it moved over there. This times that. So let me clear out that and say 31.36 times the sine of 12.6. Sine of 12.6 is just a decimal. Decimal times that, it's going to make it smaller. 6.84 newtons equals g sub x. All right, now we'll partition this with a nice outline. I just like to do that so it doesn't look like a sea of numbers, that you can actually tell where the scratch work for one problem has been done versus another. Okay, so that takes care of that. Now, that's 1, 2, 3. Fourth, I might ask you, what is, or let's see, what do we usually find? Oh yeah, friction. We want to know, since g sub x is 6.84, we know 6.84 is pointing in that direction. So will the friction be able to support it? The only way we can find out is to take this mu value and use this equation. The equation for static friction is less than or equal to mu times the normal force. So there's another reason why it's important that we know what the normal force is. The normal force is going to be whatever g sub y is, assuming the ramp can support it. And I didn't say anything about that, so we're just going to assume that it does. So let's plug in g sub y for the normal force, 30.6 newtons, times mu, which is 0.3, and less than or equal to force of friction. So this times that, let's find out, 30.6 times 0.3. This is essentially a third of that, so 9.18 newtons. That's the friction can hold up to, that's what this less than or equal to means. Friction, the force of static friction can hold up to 9.18. Compare that to this. This isn't strong enough to break through the friction. So, in other words, while this is pulling the block down at 6.84, friction's only going to oppose it as much as it has to, right? Like the more we pull, the more friction is going to try to not let the block slide. And that'll continue to be true as long as this number doesn't get bigger than that. As soon as it gets bigger, that's why it's less than or equal to. As soon as this, if this happened to get bigger than that, then the block would slide. So if I were to ask you the question on this problem, will the block slide? You'd have to say no, because G sub x is not bigger than the force of static friction. And that is really how you do these problems. So hopefully that made sense. And very important, if you're going to do problems like these, that you practice over and over and over. And what you can do is do the problem again, only change the mass, come up with your own mass, come up with your own angle, come up with your own mu value. And the only thing you really have to watch for is you don't want to make theta bigger than 90. It should never be 90. It should be between 0 and 90, somewhere in there. And then the mu value shouldn't be bigger than 1. I think there might be some cases where mu is bigger than 1, but it's essentially, the smaller this gets, like if we went 0.02 or something, that'd be like ice. And if you get up to 0.7, that's like, I don't know, rubber on pavement or something. And higher than that might be like sandpaper on sandpaper. I don't know. But you can actually look up your mu values on the internet if you want. But once again, to do these types of problems, to practice these types of problems, make up your own mass, angle, and coefficient of static friction, and then have somebody who's also working on these do the same problem. And if you guys both come up with the same answers, you probably did it right. Otherwise, if you didn't, then try to figure out where one of you went wrong. Good luck.